I'm going to give you some tips on Sapling homework 6, questions 15 and 18. And I want to do question 18 first because it is easier. So we'll get the easier one out of the way. So this one is asking you to complete this representation of a lipid bilayer using, you've got these 4 options. These are going to be fatty acid tails that you have to drag into the correct spot on the diagram. So there's 2 components of selecting the right fatty acid tail. One is expecting that you would know when you're looking at these bubble diagram representations, the color coding on these representations. The black spheres on this representation are the carbon atoms, and the little grayish white spheres are the hydrogen atoms, and the red are the oxygen atoms. And so that means that you need to know the correct orientation of these fatty acid tails. Is it like this with the red spheres near the heads, or is it like this with the red spheres at the end of the tail? So if you flipped through your notes, you'll see that the red spheres, the oxygen atoms, are the connection point between the tail and the head. So you want ones that look like this for the up ones, and then down here like this. This is the correct positioning of the oxygen atoms. That's only one part of the problem, though. The other part of the problem is saying that we want to select, I'm reading the instructions here, add the fatty acids into the lipid bilayer to indicate a structure that, when incorporated into a phospholipid, would result in a more fluid membrane with a lower melting point. So this is asking you to think about what you know about the shape of a fatty acid, carbon chain, and the relationship between its shape and melting point. So if you're looking way back in your notes when we were first talking about fats and oils, we were talking about saturated versus unsaturated, cis versus trans, and how those different shapes and saturations affected the melting point. And we learned that if you have a unsaturated with a kink in the carbon chain, like is being shown here, that is going to result in a more liquid and lower melting point for the fatty acid. And that is also true for the lipid bilayer. I can't get that guy to go where I want him to go. So these tails, which are nice and straight chain, linear, those would be more solid and not as fluid as the ones that are all kinked up. So this guy keeps turning itself around. That's the structure that we're looking for right here. So that's question 18. The other one that I want to look at is question 15, because I feel like when you look at this question, it's probably going to intimidate you. It's probably going to freak you out. So what you need to do, first of all, is look into your notes on section 19.6. You drew a structure of a lecithin, and that's what this problem is asking you to do. It wants you to draw a lecithin. So you can copy what you have in your notes. You've got a 3-carbon backbone for your lecithin. You have got, you don't have to show hydrogens because it's looking for a line structure, so that's wonderful. You learned that you've got oxygens. You've got 2 oxygens coming off like that. And then you know that up here you've got 2 carbon-oxygen double bonds, like that. So, oops, I didn't want that. This is going to be difficult for me to do because I'm working on a tablet, and hopefully you're not also trying to do this on a tablet. So I'm putting in my carbon-oxygen double bonds, and I've got to kind of angle them in a weird direction just because I don't think I can move this drawing. And this will help. And then you want to put, I think the next thing I would do is go back up to here and put my carbon chain. So at carbon number 1, it's telling us that I have CH3, CH216, and then the COOH. This, not that, this carbon right here is the COOH carbon. This carbon right here is the first of the 16 CH2s. That would be number 1 of the 16. So I need to continue this chain down until I get 16 of them, which I'm not going to take the time to do that, and then add 1 more for the CH3. So all together, this is going to be number 1, and then you're going to have 16 of these guys. Once you get all 16 of them, then you're going to add 1 more at the end for a total of 18, including this carbon right here. That's going to be your carbon number 1. Carbon number 2, it says it wants oleic acid, and it gives you the formula for that. CH3, CH27, CH double bond, CH, CH27, COOH. Here's your COOH, this guy right there. You need 7 CH2s, which are these guys. And I will put all of those guys in. So there's 1, 2, 3, 4, 5, 6, 7 CH2s. Then you need a CH double bond CH. So here's our CH double bond CH. Now you're going to need 7 more CH2s. You're going to have to count 7 more of these guys and then 1 more CH3 at the end. So there's that. Then for your last part on this, we're drawing a lecithin. So for the last part down here, you need to fit in that bottom tail that is characteristic of a lecithin, and it's the same for all lecithins. So that's where you want to look in your notes, and you're going to ask yourself, what does that look like? Now, it's going to be okay if you draw that tail to the right rather than trying to fit it in off to the left the way that you did in your notes. Or I'm going to maybe try to angle mine down like this to make it fit better, because there's not a whole lot of room in this window. And what I need you to do is copy exactly what you have in your notes. So there I have made the phosphate group. Now, before we go too far, remember, you've got to have that negative charge on the oxygen. If you don't have that negative charge on the oxygen, Sapling is going to mark it wrong. So there's your P with 4 oxygens. One of them has a double bond. That one that I've drawn with the negative charge, it has to be that one with the negative charge. You can't just stick a negative charge on anybody. Now the next thing that we have there is a CH2 and then another CH2, and then as you know, there's going to be a nitrogen attached. So there's our nitrogen that we've attached, and the nitrogen has got 3 CH3s on it. So there's 1 CH3, 2 CH3, 3 CH3s, and then you've got to have positive charge on that nitrogen as well. So I'm not going to hit check answer because I know that this is wrong, because I did not, up at the top, I did not complete my carbon chains. So I know that this would be wrong. But down here at the bottom, this phosphate and amino alcohol group, I know that this part is correct. So this is going to be a tricky problem. If you do get it wrong the first try, most likely you've made a mistake in your carbon chains up here. So go back and recount all of your carbons and make sure that they are all there and that you don't have an extra one or you're not missing one.